In the heart of our solar system, a celestial titan blazes with unfathomable fury. The sun, a glorious beacon of light and life, fuels our existence with its radiant energy. Yet beneath its incandescent beauty, the sun harbors a darker side. Its roiling surface and vast nuclear furnace hold forces so destructive they could spell the end of life as we know it. Visualize a future where the shifting life cycle of our star engulfs the Earth, or a universe where the sun explodes in a final breathtaking act of stellar destruction. While these scenarios might sound like science fiction, they're grounded in the terrifying truths of astrophysics. Don't believe me? Well, let's venture into the realm of solar cataclysms and cosmic hazards, and you'll gain a profound appreciation for the fragile balance that allows life to thrive on our little blue planet. Number 1, solar flare cataclysm. Starting our list, we have solar flares, which are sudden, violent eruptions of energy on the surface of the sun caused by intense magnetic activity. This explosion of energy releases a burst of radiation across the electromagnetic spectrum, from radio waves to X-rays. The most powerful solar flares can unleash energy equivalent to 1 billion atomic bombs. While the Earth's magnetic field and atmosphere protect us from most of this radiation, a large enough flare could potentially cause catastrophic damage. The largest solar flare in recorded history, known as the Carrington event, occurred in 1859. It caused worldwide disruptions in telegraph services and reportedly gave rise to auroras that were visible as far south as the Caribbean. If a similar event were to happen today, the consequences could be far more severe. Our modern society relies heavily on electronics and satellite-based technologies for communication, navigation, weather forecasting, and more. A powerful solar flare could damage or destroy these systems, causing widespread chaos and potentially costing trillions of dollars in damage. The recovery from such an event could take years, if not decades. Moreover, the radiation from a large solar flare could also pose a threat to astronauts in space, outside the protective shield of Earth's magnetic field and atmosphere. This is a significant concern for long-duration space missions, such as a mission to Mars. Number 2, solar system meltdown. The sun is gradually getting hotter. Over the next billion years, it's expected to increase its luminosity by about 10%, which doesn't sound like much, but it's enough to cause a runaway greenhouse effect on Earth. This will result in the evaporation of our oceans and a significant increase in the surface temperature, rendering the planet uninhabitable for most forms of life. Thus, the term solar system meltdown is just a dramatic way of referring to this long-term warming trend. It's a reminder that our planet's comfortable position in the Goldilocks zone, the region around a star where conditions are just right for liquid water, is only temporary. In the far future, about 5 billion years from now, the sun will exhaust its hydrogen fuel and enter the red giant phase. During this phase, it will expand enormously, swallowing Mercury and Venus, and possibly even Earth. This is the ultimate solar system meltdown, a natural part of the life cycle of stars like our sun, and if it occurs, it might very well be the end of all life on Earth. Next up is the solar vortex, or a coronal hole, which is an area on the sun's surface where the solar magnetic field opens up and allows streams of solar particles to escape into space. These particles form the solar wind, which is a constant stream of charged particles that flows outward from the sun. When a coronal hole faces Earth, it can cause a high-speed solar wind stream that interacts with Earth's magnetic field, potentially causing geomagnetic storms. These storms can interfere with the operation of satellites and power grids and increase the radiation exposure for astronauts and air travelers. While not as destructive as a large solar flare, a solar vortex still poses significant risks to our technology-dependent society. The solar wind can also strip away a planet's atmosphere over billions of years, which is believed to have happened to Mars. If the Earth were to lose its protective atmosphere, it would become a barren, lifeless world. Number 4, solar black hole. At number 4, a bizarre cosmic event unfolds and a microscopic black hole mysteriously materializes within the sun's core. Initially concealed by the sun's intense gravitational forces, its insatiable appetite for matter gradually becomes apparent. Feeding on the sun's energy, the miniature black hole grows, relentlessly siphoning off the sun's fusion reactions. This results in a rapid decline in the sun's light and heat output, casting the Earth into an eerie darkness. Daylight becomes a distant memory as the once vibrant blue skies are replaced by an oppressive shroud of blackness, plunging the planet into a perpetual winter. Ecosystems suffer catastrophic consequences. Deprived of sunlight, plants wither, triggering a chain reaction that disrupts the entire food chain. Human civilization grapples with unprecedented challenges. Agriculture collapses without sunlight, causing widespread famine and scarcity. Crops fail, livestock perishes, and dwindling food supplies push societies to the brink of desperation. Survival becomes an arduous struggle. Resource scarcity intensifies competition, fueling the threat of social unrest. Governments and communities desperately seek alternative energy sources and implement rationing systems, but the darkness persists, pushing humanity to its limits. Amidst dire circumstances, scientists tirelessly work to comprehend the nature of the black hole and develop strategies to mitigate its devastating effects. However, their efforts are hindered by a limited understanding of these cosmic anomalies and the rapidly deteriorating conditions on Earth. As the black hole continues to grow, its gravitational influence wreaks havoc on the planet. Immense tidal forces induce violent seismic activity, tsunamis, and volcanic eruptions. The Earth's surface fractures, swallowing cities and rendering vast areas uninhabitable. Ultimately, the black hole consumes the remnants of the dying sun, reaching a critical mass. Overwhelming gravitational forces trigger a cataclysmic release of energy. The resulting explosion scatters debris and unleashes a final burst of radiation, engulfing the solar system in a tragic end to all that once thrived. Number 5, the sun blowing up. Lastly, let's discuss the term the sun blowing up, which is often used in popular science to describe the end of the sun's life cycle. However, it's a bit of a misnomer, and stars like the sun just don't blow up in the same way that a bomb might. Instead, they go through a process of expansion, shedding their outer layers and eventually collapsing. As mentioned earlier, the sun is currently in the main sequence phase of its life, where it is burning hydrogen in its core. This phase will last for about 10 billion years, and the sun is currently about halfway through it. Once the hydrogen in the sun's core is exhausted, the core will start to contract, and the outer layers of the sun will expand. The sun will then become a red giant, and it will be large enough to engulf the inner planets, possibly including Earth. After the red giant phase, the sun's outer layers will be ejected into space, creating a planetary nebula, and the core will collapse into a white dwarf. This white dwarf will slowly cool and fade over billions of years. Although the idea of the sun blowing up is certainly terrifying, it's important to remember that this event is billions of years in the future. It's also worth noting that long before the sun reaches the end of its life, changes in its luminosity will likely render Earth uninhabitable. In conclusion, while the sun is the source of life on Earth, it also has the potential to cause great destruction. Its intense energy can cause a plethora of problems for us, and its long-term evolution will eventually lead to the end of Earth as we know it. However, this may only occur over astronomical timescales, and although it's essential to be aware of these potential threats, they also serve as reminders of our place in the cosmos and the importance of exploring and understanding the universe around us. What other changes could the sun undergo that could spell disaster for the Earth? What do you personally think about this? Tell us in the comments below. This brings us to the end of this video. If you liked the video, please consider subscribing and sharing so we can keep bringing more content like this. See you next time!